Hey everybody, Mac here from the Raspberry Pi Foundation. We know that with the big change to homeschooling we're all doing at the moment, it might be a bit daunting for you to get your kids coding at home. Last time, my colleague Mark gave you an introduction to the Scratch programming language, which works great for younger students. However, some of your children might feel that they've outgrown Scratch a little bit. So this week, I'm going to show you the Python programming language and give you some tips on how you can get your children set up and using it at home. Python is a text-based programming language, which means that your child will have to type out each of the commands letter by letter themselves. Now, it's quite difficult to say when somebody should move on to Python from Scratch, but as a guideline, we can have a look at the national curriculum. Now, we can see here in Key Stage 3 that students are expected to use 2 or more programming languages, at least one of which is textual. So that means languages like Python. Now, Key Stage 3 covers ages 11 to 14, so that can serve as an initial guideline for us. In my experience, age isn't always the best way to measure whether your child is ready for Python or not. Really, it's more about their confidence using a computer. Textual languages require them to proofread more than block-based ones, so they need to be able to look at what they've actually written and not what they think they've written. And it's also important they have a little bit of confidence typing, and they're not going to spend 5 minutes looking for every letter, because that can just add additional frustration and make the experience unpleasant for them. That being said, Python is very welcoming for beginners. It's typed in plain English, and there are loads of guides out there to help your child get on with it. So if they do have a bit of confidence and you feel like they could persevere, I reckon it's good to give a go. There are a couple ways for you to get hold of Python for your child to use. You can either download and install it on your local machine, or use an online service like Trinket to write Python code in a web browser. If you want to download it, you can go to python.org/downloads to download the latest version absolutely free. In this video, and in lots of the projects on the project site, we use an online service called Trinket to run Python code. Now to do that, I'm going to use the website Trinket, which you can find by going to trinket.io. Attached to this week's post is another video by my colleague Mark introducing you to Trinket. It's a great website and you can use it to program in all kinds of languages. I couldn't do an introduction to Python video without showing you some Python code and explaining the interface to you. So like I said, I'm going to use Trinket to do this. I've got 3 pieces of code I'd like to show you. This first one is called the Hello World program, and it's a very typical first program that someone would write when they're just starting out in a new language. You can see in my window here I've got 2 halves. I've got the side where I write my code and the side which shows my output. So anything that I push out of my code here is going to show up in this side over here. In this case, the Hello World program just prints a simple message, Hello World, to the screen. There we go, Hello World. Now in the code editor over here, there's 2 parts I'd like to look at. The first is the command print. Now print just outputs whatever's inside the brackets to the screen. Like I said, Python is a very plain English typed language, and so they try to use commands that make sense to you. And print really evokes the idea of giving something out or printing something out of the computer. Now I can change the message inside of here if I want to and say hello to all the digital makers out there, and my print statement will then output a different message. And go, hello digital makers. Now at the moment, my data, which is this part here, is hard-coded. I can tell this is data because it's got quotation marks around it, which means Python will ignore it as code and instead treat it as a message or data. Now typically we don't hard-code, put our data straight into the commands, we use variables instead. So I'm just going to make one now. Now I can call my variable anything I like, but it's good to give variables names that indicate what they do. So I'm going to call this one message. And inside this message, I'm going to write a new message to say hello to the parents. Or not hello parents, hello parents. Now, if I want to output what is stored inside of message, which is just a way of me giving a name to a piece of data so I can refer to it later, I can pop it in between these brackets here. And you'll notice that I haven't put any quotation marks around it this time because it's a reference to the variable I just named up here. And then if I run my code, we should see, perfect, a new message comes out. Now I'm going to show you another piece of Python code. This time I've got a countdown timer. So this will start at 10, count all the way down, and then say blast off. So you'll notice it's got another variable called timer, which is how long my program will run for. And then here I've got a new structure called a loop. Now this will keep going round, repeating, until the condition up here is no longer true. So it will keep repeating while timer is greater than 0. And then each time it'll print that value out and then take 1 off of it. which should give me my desired countdown effect. Perfect. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. Now, you can see here as well that there are more commands, so while has been highlighted in pink, and that is so that you don't accidentally call one of your variables the name of a command. So I can't call a variable print because Python already has a meaning for that. Now I can change this and make it run from 50 if I want. And then it will start all the way up here at 50 and count all the way down to 1 and say blast off. Just in this way I can change variables and change how my code reacts. Now let's have another look at an example of that in this last program. So this one is an outfit recommender, or a safety precaution recommender you could say, for when I go outside for my daily walk. So I can input what the temperature is, and then depending on the results it'll print me out different things. So if it's greater than 20, I'll make sure to remind somebody to put on sun cream. If it's not greater than 20 but it is greater than 10, I'm going to say let's put a jumper on. And then for any other temperature, which means it must be below these two values, I'll ask them to put a jacket on. So let's just run my code. Perfect, and then I can type in 5 and I should get told to put a jacket on. Amazing. And if I run it again this time, now notice I haven't changed anything in my code this time, but if I just input a slightly different value, I get a different result. And that is because I'm using these if statements here to change how my code reacts depending on what I've input. So what should you expect when your child starts using Python? Now the main thing to look out for is small spelling errors. As with any typed language, these are quite common when you're first starting out. I'm just going to give you an example here. So at the moment we're printing the variable message when we run our code, but if I just change this to a capital M here, Python is now going to throw me an error. It's going to say this doesn't work anymore because the name message with a capital M is not defined. And that just means that nowhere have I told Python what this means. Now, I would explain that computers are really, really dumb and they don't understand language in the same way we do. So even though you and I can look at these two words and tell they're the same, Python thinks they're completely different because this one has a capital and this one doesn't. Okay? So that can be quite frustrating if you're just starting out. So a really big help that you can give them is just to help them read through their code and double check that what they've called their variables is what they're using when they access them. Another thing is just to help them read through the guide that they're using. So all of our projects are very well documented, and so a big help can just be helping them reread through the instructions so they understand what they're supposed to be doing. This is a good way for you to empower them to fix their own issues, but it's also a nice way for you to understand what they should be doing. So you've seen what Python is and have a little idea of what to expect when your child starts using it. So some of you might want to have a little go at Python before moving your child onto it. If you'd like to do that, the best place I can recommend is the project site from Raspberry Pi, which you can get to by going to projects.raspberrypi.org. Here we have a selection of computing projects that use all sorts of hardware. You can filter them by topic or hardware, so if you happen to have any of these pieces, you can filter by that. But in this case, I'd recommend just filtering by Python in the software, and then you can also choose a level. Now, Creator is probably the best one if you've never programmed before, or you just want to have a little go at it without too much challenge, but you can also have a go at the later levels as well if you're feeling a bit more confident or if you've coded quite a lot before. If not though, just stick to Creator projects. Python is an awesome language and we have a ton of resources for your child to use to get involved with it. The first thing I'd like to talk to you about is our Digital Making at Home scheme, which is our weekly content series for children to code along with at home. Every week we set a new theme and provide resources at 3 different levels so that your child can find the right level of content for them. Now in the first week, the first theme of making games, the advanced level projects involved Python, particularly creating a turtle race. Now this is where we use drawing tools in Python to race a few turtles. I definitely recommend this as a great starter project for people getting used to Python. Alternatively, you can go on the project's website and just like I showed you for you, choose Python and level 1 Creator unless they're feeling a bit more confident, and then pick one of the projects that uses a web browser. Now 3 I would highly recommend are Colorful Creations, where you use a drawing tool again on Python to create lovely artwork to show off to your friends and make a poster. There's a password generator, which teaches you not only about secure passwords, but also lets you create a generator so that you can just one click and generate really strong passwords. And finally, we have a rock, paper, scissors game that you can create in Python. Play against the computer and see if you can beat them in this famous game. All of the resources I've shown you today are absolutely free and anyone can use them. We'd love to hear your feedback on any of the digital making at home offers or these parent videos. If there's something that you think that we could do to help you out, please let us know. We'd love to hear about it. That's all from me today. Thank you so much for watching, and until next time, happy coding.